Hello guys, welcome to All Clear Tube. Today now we are going to see non-deterministic finite automation. What is non-deterministic finite automation? NFA stands for non-deterministic finite automata. It is easy to construct an NFA than DFA for a given regular language. So it's easier to construct an NFA rather than constructing a DFA. To see how to construct a DFA, please refer my previous video. And now let's go to the next point. The finite automata are called NFA when there exist many paths for specific input from the current state to next state. This is the main difference between DFA and the NFA. So for example, there is a state Q0, Q1 and say Q2. So on a particular input A, on a particular input A, it can go to Q1, as well as for the input A it can go to Q2. So this is what is explained in this point. It can go for many paths, but where in the case of DFA, for a specific input it should go only to only one state. NFA contains multiple next states and it contains epsilon transition. And every NFA is not a DFA, but each NFA can be translated into a DFA. Now let us see the formal definition of NFA. It is very similar to DFA. NFA is also represented by a phi tuple, and Q is the finite set of states, and sigma is finite set of input symbol. So states, as you know, is the it can be Q0, Q1, so the states of the machine, and sigma is the finite set of input symbol, say A, B, or 0, 1, something like that, and Q0 is the initial state, F is the final state, and this is the transition function. Delta is the transition function. Only the only difference between the DFA and NFA is the transition function. So since for one input it can go to multiple states, the transition function would be like this: Q into sigma is 2 power Q, where Q is the finite set of states available. Now let us see it with an example to understand the concept. Construct an NFA that accepts strings starting with A. So our language starts with A. So what we are going to do is A. So it should start with A, and after that we don't care, like it can be A or B. Now let us see another example. So let the language be containing A, string containing A. So the NFA will be A. It can be A or B. So since it should contain A, and this is the final state, and it can contain A or B. So another example starts with AB. So it should just start with A and B. So first state and A here, B, and in the final state can be either A or B. So these are the NFAs. Guys, that's all about NFA. Please like the video and subscribe to our channel and click the bell icon.